Okay, good afternoon. My name is Roger Hoyt. I'm the President and CTO of Integrated Data Technology. Hopefully everyone is seeing my screen and can hear me.
Yes, looks great. Sounds great. Thank you.
Okay. I just want to start about introducing the company, Integrated Data Technology. We're a leading business technology company here in New York, and we have been in business for over 30 years. We were founded back in 1988 with core specialties in ERP, CRM consulting. Well, I just want to start off that today's topic that I'm going to talk on is the cloud and beyond. So we are here right now utilizing the cloud every day, whether or not we're using ERP and CRM that are hosted out in the cloud somewhere, or we are utilizing some type of device that is sending data to the cloud. Today, the cloud encompasses just about everything that we need to really successfully do a digital transformation. It's one of the foundational pillars of digital transformation. Well, with all this data being created every day, we have to stop and ask ourselves, well, how is this being done? Well, it's being done by a number of technologies that have embraced cloud computing as its source and resource for operating. I mean, from mobile technology, machine-to-machine communicating, 3D printing, advanced robotics, big data analysis, the Internet of Things, which is probably is taking over in terms of the amount of data that it's producing every day and sending to the cloud. Another technology out there that is really utilizing the cloud now is cognitive computing. And you heard that a little before with Yuma talking about how the retail space is actually utilizing data being produced to give better experience to customers. But with all the data being produced and being sent to the cloud, it's causing somewhat of a problem in certain sectors. For someone using an ERP or CRM, it may be great because we are no longer tethered to our desk or have to be in one place geographically to use that application. We can now leave our desk, walk around, and still have access to that data thanks to cloud computing and the fact that we can now have those applications running on mobile devices. So we no longer need to be in one central position. The problem with that is it works great for certain things, but the cloud has reached its limits, so to speak, when applied to certain sectors. And those sectors would be something like, a good example would be the autonomous vehicle. Lots of data, but we really can't use the cloud to power it by itself because we need data in real time. And the cloud, as it stands, when we send a piece of data, who knows where it goes? The server in which it's being stored at could be somewhere out in Norway or Switzerland. And the time for that data to get to that server, acted upon, and return to us with something, it's not good in terms of real-time demanding applications. It's great for like a CRM, not great for autonomous vehicle. You could just imagine if the autonomous vehicle was to see a red light ahead and had to act on it, it sends that data up to the cloud some way back. By the time that data comes back telling it, hey, you need to apply brakes, it would have gone through the red light, knocking who knows how many cars, probably killing people. So that's not the greatest example in using cloud computing in that particular sector. Let's stop a little bit here, but and talk a little bit more about the benefits of the cloud, because there's a lot of benefits as it stands. We know that the cloud has improved productivity, meaning that, like I said early on, that we were able to move from a centralized location and have people move around and still use the application. Therefore, productivity can be increased by the mere fact that it's accessible any place and any time. We know manufacturing has benefit from that because, hey, now we have applications running and supporting remote locations, thus meaning that we don't have to duplicate our efforts in every place that we are. Next, we know that it has improved safety management because now we're able to pull workers off the floor, out of harm's way of moving machinery, and still monitor safety from afar. The cloud has been an enabler of that. And lastly, we know that its benefit by having this huge ecosystem in which it can integrate with other applications and source data from other places, all in at the same time without having to be worried about integrations from premise to premise. One of the big things that you will realize here is that the cloud has really addressed many things that we in business want to have. But at the same time, it has introduced some problems that we need to address. And with that is where we are go to the beyond. And we're going to talk about two technologies that is going to be redefining the cloud as it is today. So let's step back and first to see where we came from and where we're heading. Back in the 1960s, between 1960s and the early 70s, mid 70s, I would say, we started with the mainframe, and that was somewhat an operational environment similar to what we use with the cloud. We had this one gigantic big computer room, and we had dumb terminals connected to it. Then comes the 80s. We were able to shrink the size of a computer down to a small box and introduce something called client server, thus increasing the number of people that can actually access and source information. That was a great leap for us. Then came the 2000s. From 2005 to now came the whole cloud technology. And that was revolutionized by the fact that we had mobile technology coming aboard and we could have applications running on our in a browser or on our cell phones that access the same data and can act upon it. Well, that's great that I give you the example of autonomous vehicles. That didn't work for autonomous vehicles. So we now get to the point where we are now in the 2000s and beyond, where we are now talking about edge computing, in which we are going to have very fast transmissions of that data because the applications we want to use, such as autonomous vehicles, telemedicine, advanced robotics, want to have real-time access of data and really need to compute on them. So let's focus in a little bit more on what the cloud is going to be like. We're going to have these edge servers and edge devices sitting in our hand or out in the near cloud, acting upon data that's being produced by IoT devices, autonomous vehicles, precision manufacturing, and others out there. This will lead to greater manufacturing capability and better productivity as we move along. So we're at the point now where I want to introduce the two technologies that is propelling this change, namely the advent of 5G and edge computing. So let's start with 5G. Well, 5G is the 5th generation of telecommunication that supports ultra high speed and responsive networks.
Roger?
Yep.
Hi, this is Kevin. Sorry for interruption. You have 5 minutes. Thank you.
Thank you. So I'm going to speed up here. Because of high bandwidth and low latency, we can now utilize such things as autonomous vehicles, utilizing the network and processing real-time data, because the speed of data that we move is going to be so fast. Every sector is going to benefit from 5G, whether they use IoT, whether it's critical applications or enhanced broadband, such as now that we are having 4K televisions and stuff. We'll be able to move massive data down to the end user for better experience. So a bit about edge computing. Edge computing is distributed computing in a nutshell. Basically, we'll have on the edge of the cloud servers that are specialized to act upon data that come in from certain sources. This will make the things like, again, like autonomous vehicles work and better as they move forward in production. A bit more about edge computing I want to say is that right now we're utilizing some edge computing and we don't know, but basically it sits at the bottom of the edge closer to where the use of that data is needed. And the layout here shows you somewhat how that is done. So if you look at a comparison between a pure cloud as we know it today and cloud when we have edge computing working, you can see the benefits right away of edge computing. If data need to be acted upon in a real-time basis, then an edge server or edge device is capable of doing it, because we could just do that calculation instantaneously, send it back to that device, and then slowly propagate the cloud for data storage. Cloud computing, we had to send all the data up to the cloud, acted it in the cloud, and then send it back, which kind of slows down and really delays the efficiency of that machine. So some of the benefits of edge computing is cost effective, it increased interoperability, it adheres to faster response time, reliable operation by just using intermittent bursts of communications. And lastly, we go to the layout of how it is. This is typical what would happen as the cloud moves beyond. It moves to the point in where we have the cloud layer, which is really becoming a storage layer, to edge computing, which is the area in which we're going to be acting upon data, and then the edge devices, which is really going to utilize that data as it comes down. Lastly, this leads to the statement that when we think about cloud computing, we should always think this statement: centralize what we can, distribute what we want. And that being that for critical applications, distributed computing is preferable over the centralized computing capability, just for the sake that that we need to have data back to us in real time, whereas in a low critical application, we could continue to use the cloud as is right now. It also leads to better user experience in everything. That's all I have. Like I said, this is a topic that can take 5 hours just discussing. I just condensed it into a little over 12 minutes. Thank you very much.